Hi and welcome to this short video, which is just going to be an introduction to how you calculate the molar mass of a substance. So if you're doing stoichiometry calculations, you're trying to work out mass or number of moles, or if you're getting into concentration volume calculations further on in analytical chemistry, really good skill is just to be knowing how to work out the molar mass of a substance really quickly. So the molar mass is the mass of 1 mole of any particular substance. To calculate it, what you do is you add up all the atomic masses from the periodic table. Okay? And the units for molar mass is grams per mole. So I'm just going to do a couple of quick examples so you can see what I'm talking about. So I'm just going to start off with something like phosphorus trichloride, PCl3. So if we want to know what the molar mass of phosphorus trichloride is, you need to look on the periodic table and find the mass number. Okay, so I'll just show up on the screen here. It's a symbol you kind of see from the periodic table, and you can see we've got atomic number and we've got mass number here as well. The mass number is always the bigger of the two, and it's the one with the decimal. And so for phosphorus, I'm just using a periodic table on my phone for the moment. For phosphorus, the mass, atomic mass is 30.974. That's for phosphorus. Okay, and for chlorine, off the periodic table, the atomic number is 35.453. Okay, so just getting those off the periodic table. Okay, now what we do is we look at how many of each we've got in our molecule up here, and then we add them together. So we've got 1 phosphorus up here, 1 phosphorus, and there's 3 chlorines. So what we're going to do is we're going to multiply the chlorine by 3. Okay, and then we're going to add to that 1 of the phosphorus. So 35.453, we're going to multiply that by 3, and then we're going to add in the phosphorus, and we're going to get a value of 137.333. Now that is the molar mass. Molar mass, we give the symbol big M, capital M, okay, and the units is grams per mole. Okay, so that's just a simple calculation to begin with. I'm going to show you 2 more just in this video. Next one I'm going to show you is involving a few more atoms. So now what I'm going to do is I'm going to look at something like sodium bicarbonate, so NaHCO3. So sodium bicarbonate has a sodium, it has hydrogen, it has carbon, and it has oxygen. So we need to find the values for each of these off of the periodic table. So for sodium, the value is 22.99. For hydrogen, the value is 1.008. For carbon, the value is 12.01. And for oxygen, it's 15.999. Now, sometimes depending upon the periodic table you're using, how many decimal places they go to, these numbers might differ a little bit. But if you're doing this in the exam, just make sure you use the periodic table values that they give you. So each of those are the atomic masses based off the periodic table. We now have a look at our formula. So up here in NaHCO3, okay, we've got 1 sodium, so that's going to be multiplied by 1. We've got 1 hydrogen, so that's multiplied by 1 as well. We've got 1 carbon, so that's multiplied by 1. And we've got 3 oxygens up here in the formula, so we're going to multiply that by 3. We're going to add all of those up together. And basically the only one you really need to multiply, obviously, is the oxygen. Then you add in all the other values, and we get a value of 84.005. So that's the molar mass, again, capital symbol M. Molar mass is grams per mole. So all you're doing is looking at the formula, finding the relative atomic masses off of the periodic table, adding them all together to work out your molar mass, taking into account the ratio. So we've got 3 oxygens, that's why we multiply by 3. I'm going to show you one more. Final one I'm going to show you is going to be something a little bit different. So I'm going to do copper chloride, okay? But I'm going to put in what's called some water of crystallization. So I'm just going to say that this has got 2 water of crystallization in it. So sometimes when ionic substances form a solid, water molecules stay within the structure there, and that's called water of crystallization. You can see that by the fact that we've got these 2 H2O here. All right, so that means the ratio for every 1 copper chloride we've got in there, there's 2 water molecules in there. Now, mistake a lot of people make in this is that they do the dot there as a times, but that's not the case. You just look at this, the atoms you've got in this substance. So again, we've got a copper, we've got chlorines, we've got hydrogens, and we've got oxygens. Okay, so if we're looking at copper, firstly, here's copper, mass number of 63.546 off of the periodic table. Chlorine we did before was 35.45. Hydrogen is 1.008 and oxygen is 15.999. So then you have a look up here at your formula and you work out how many of each. Copper, we've got 1 times 1 there. Chlorine, we've got 2. That's pretty straightforward. Now you look for our water and we've got 2 times 2 here. So that gives us 4 hydrogens in there and 2 oxygens there, which is a 2. Okay, so now what we're going to do again is we're going to add all of these up and we're going to get a value of 170.476 grams per mole, and that is our molar mass. Okay, so that is the mass of 1 mole of a substance. All right, you might want to look at the video about an intro to the concept of the mole as well. That might be a good one to have a look at. But simply for molar mass, it's just adding up all the atomic masses that you find off the periodic table. Okay, the units are in grams per mole. Hopefully this has been pretty straightforward. If you've got any questions, just ask. Thanks, guys.